Let us talk about this simple problem on queue data structure, which is reversing the queue. We are given a queue which has certain elements and we need to reverse it. What do we mean by reverse? The last element should come first, then the second last element, then the third last, and then the first element. So this should become our new front. How do we reverse a queue? Please pause this video and think of a solution for a moment, and then you can play it again. Please note that there are two solutions to reverse it. One is iterative and one is recursive. We are going to talk about these two solutions after you try it yourself. The iterative solution is simply traverse through the queue, put every item of the queue into a stack, right? Take the item from the queue out and put it into a stack. So when you put items into the stack, their order is reversed, when you pop the items from the stack next time. Stack is used always for this purpose. So we take out items one by one, push them into the stack, and then we traverse the stack and push those items back to the queue. Let's see how does this work. So we create a stack. I have written here C++ style code. If you are programming in Java, then you can use this structure. Right? You don't need to put this reference here because by default things are by reference in Java. Their references are passed. In place of stack, you can use stack integer, right? And in Java, the stop and pop can be done in one line. So if you're doing in Java, it will be s.push q.pop, right? So these two can be done in one line. These two can also be done in one line. q.push s.pop. Actually, it's remove in Java, so it will be removed, and it's add in Java, so it will be add s.pop. Okay, so that's about the language specific things, and these blue things are about Java. So what do? We traverse through the queue items one by one, take them out and put them to a stack. So this is where we put them to the stack, and this is where we take them out of the queue, right? And this can be done in one line in Java. Now we traverse through the stack and we take the top item, put it to the stack and remove it from the stack. Let's see how does this work. Say we have a queue 12, 5, 15, 20, right? And we create an empty stack. What do we do now? We push all the items of this queue into the stack and remove them from the queue. So this 12 is pushed, removed from the queue. This 5 is pushed, removed from the queue. And 15, and 20. So this is our stack now. Everything is removed from the queue. So queue is empty. Now what do? We take out these items one by one from the queue and put them to a stack. Put them to the queue, right? So we take out the items from the stack and put them to the queue. So 20, 15, 5, and 12. This will be our queue, right? Because we will be removing the last added item. So this is how we reverse the queue, right? If you're programming in C++, you can use this code. If you're programming in Java, you can just make these modifications, these blue changes. And obviously this function will be isEmpty in Java, right? So let's now talk about recursive way of solving it. How do we recursively reverse the queue? So in recursion, what we need to do is, we need to think this way. Say I handle the n-1 items of the queue, where n are the total items. How do I handle the nth item, right? That's what we do generally in recursion. So let's see how do we solve it using recursion. So queue is this. Say I somehow reverse these n-1 items of the queue, right? Say I reverse them using recursion, 20, 15, 5, right? Now how do I handle this item? So I can just do dequeue on the queue or remove or pop on the queue. Basically they are all used for the same purpose. So I remove this item mainly. And what I do, I recursively reverse the remaining n-1 items, and then I push this item when I have reversed the remaining part. So I take out this item and I make the queue as 5, 15, 20. I have mainly removed the first item, and then I reverse it recursively. So my queue becomes 20, 15, 5. I assume that recursive function works, right? Now what I do, I put this item at the end. So my queue becomes 20, 15, 5, and then at the end 12. Right? So this is my reversed queue, right? This is my reversed queue. Same thing we have implemented here in this code. What are we doing? We are taking the top item. So if we're programming in Java, it's simply x equal to queue.pop, one line only. Right? We are taking the top item, storing it, and then removing the top item. Right? So what have we done here? We have removed this 12 from the front, right? In these lines. Now what do? We recursively reverse the remaining queue. We reverse these remaining 3 elements. So we are here right now. We reverse it recursively. Now what do? We add the item back. So this is what we do. We add this item back here. And this is what we did here. We reversed it. Right? So we took the top item off. This is what we did here. Right? We took the top item off, reversed the remaining queue, and added the taken item back to the queue. Right? So when you're removing the items one by one, you need to handle the base case, right? That's what you do in recursion, because you're reducing the size to 1, 1, 1, and there'll be a situation where your queue will become empty. In that case, what do? You simply return, because there's no point reversing an empty queue, right? So you revert return, and that's how this recursive function works. So in this video, we talked about reversing a queue, we talked about an iterative solution, then we talked about a recursive solution. So this is an interesting question where you use queue and stack both. Please note that even in the recursive solution, we are internally using a stack, right? That's the function call stack that we are using. In the iterative solution, we were using our own explicit stack.